All right, Sammy. So day three adds a couple more properties to it. Okay, starting with a quotient of powers property, right? And all this is saying, so if I gave you something like 9 over 12, okay, what you have to understand is the canceling properties. So if I reduce this fraction, we all know that it would reduce to 3 over 4. But if I break this up into 3 times 3 over 4 times 3, what happens is these 3's cancel out and leave me with 3 over 4. Okay, so when we have common bases, we can go ahead and cancel those out. Now, what happens if I had something like x to the fourth over x to the third, right? Well, if I expand x to the fourth out, that would be x times x times x times x over x times x times x, right? And now I look, these x's cancel out, these x's cancel out, these x's cancel out, and they leave me with just x. So what happens is the quotient of powers property is basically saying, what could I do with these exponents? So what this property is basically saying is if I have x to the m over x to the n, notice here, my bases are the same, right? What did we do with these exponents, right, to get this, right? Well, we write it as one base, and you can subtract the exponents, okay? Now, is subtracting always going to be easiest? No. When we get to further problems, we'll talk about it a little more, but for right now, we can get away with doing that. So let's look at some examples. If I have this here, are my bases the same? Yes. Therefore, I can write it as one base, and then I can take the exponent of the numerator, 8, subtract the exponent of the denominator, and get 8 to the fourth power. Now you can multiply that out, but it's going to be a pretty big number. Here, I have -3 as my common base. If I look, this is a common base. Those are exactly the same bases. So what could I do with the exponents? I can go ahead and subtract them. So this would be -3 to the sixth power. And again, you could evaluate that in your calculator if you want. Now the next one, what I'm going to do first here is I'm going to multiply. And remember, when you multiply common bases, what do we do with the exponents? We add them. So this would give me 5 to the 12th over 5 to the 7th. And if I go ahead and simplify it further, subtract the exponent, it's 5 to the 5th power. Over here, if I put that over 1 and I multiply across, I'd get x to the 6th over x to the 4th. And if I subtract those exponents, 6 minus 4 would give me x to the 2nd. Okay, so these are pretty easy problems. All right, pretty easy problems. Now here, don't make these harder than they need to be. But what I'm going to do here is I'm going to explain them a little differently than just subtracting, right? Now, when I look at these, this will make it a little easier when we move along further. If I look, I have 6 x's on top, I have 2 on bottom, right? If I were to write my 6 x's up top and 2 x's on bottom, how many can I cancel? 2. How many do I have left? 4. So it'd be x to the 4th. So what I like to do is just say, I eliminate the smallest exponent. I'm going to take 2 off the top, and it leaves me with 4, which means the next one, all right, I have y to the 4th and y to the 3rd. All 3 y's on bottom cancel out 3 y's on top, leave me with 1, so it's just y. And now when I do the z's, remember, this is z to the 1st, so 1z cancels off 1z. How many am I left with? 8. I have nothing left in the denominator, so this is my final answer. Okay, now quotient, power of a quotient. That is similar to the multiplication one, but if I have a over b, raised to some m power. What I could do is raise that numerator to the m power, and what I can raise to the denominator to the m power. I could also work backwards, meaning if I have a to the m over b to the m, right? I could rewrite that as a over b all to the m. All right, so let's do some examples here. The first one, very easy. X over y all to the third power. So everything in this quantity or parentheses is going to be raised to that third power. And that would be all I get. Now the next one, right? I could rewrite this as negative 7 squared over x squared, right? But what is negative 7 to the second power going to be? It's going to be 49 over x squared. Okay? Now, this one, right away when I do, I'm going to raise everything in this quantity. Everything's going to get raised to the third power. So I'm going to do negative 2 to the third. I'm going to do x squared to the third over, I'm going to do 3 to the third, and I'm going to do x to the third. So basically, I took everything inside here and raised it to the third power. But now I kind of have to simplify this. So what is negative 2 times negative 2 times negative 2 going to be? That would give me 4 times negative 2 is negative 8. But now when I raise a power to a power, what do I do with the exponents here? I multiply them. So I get negative 8x to the 6th over 3 times 3 times 3 is 27 x to the third. Now, if I look at these two numbers, could I reduce this fraction? And the answer to that is no. That cannot be reduced, so it stays negative 8 over 27. However, when I look at the x's, I have 6 on top, 3 on bottom. How many can I cancel? Cancel 3. If I take 3 off the bottom, I take 3 off the top. How many am I left with? X to the third up top. Okay. Next one, right? Everything here. At this point, hopefully we can do this. I'm going to raise 4 to the third power, which is going to give me, which is going to give me 4 times 4 times 4, right? And that's 64. Then x squared to the third power, that's going to give me x to the 6th over 5 to the third is 5 times 5 times 5, which is 125, and then y to the third. If I look, I do not have any common bases, and 64 over 125 cannot be reduced, so I leave my answer as is. All right, the next one. When I raise powers to powers, right, here, when I simplify this, that's going to give me a to the 2 times 5 is 10, right, over b is going to get raised to that 5th power, so it's b to the 5th. Now, when I multiply by 1, is it going to change anything? No. But when I go across here in the denominator, I have the 2, and then I have a squared also. So now, if I look, I cannot reduce the fraction, so I basically have 2 in the denominator. If I have 10 a's up top, 2 on bottom, how many can I cancel? The smallest amount. If I cancel 2 off the bottom, how many do I have left up top? A to the 8th. And then, can I cancel any b's? No. So b to the 5th stays on bottom. Okay? Number 7. Or sorry, this next example. We're actually going to make this, I don't know why that's there. That's going to be a t though. Okay? So now, here's what I like to do. If I know I'm multiplying these fractions, what I'm going to do is basically write one big fraction bar. I'm going to simplify these parentheses and then multiply across. So 2 to the third, right? 2 to the third, you got to remember, is 2 times 2 times 2, which is 8. That's going to be t to the third over 3 to the third is, so this to the third power is 27. And then that's going to be t to the third times, when I do this, it's going to be t to the 5 times 3, which gives you t to the 15th, over 4 to the third, which is 64. So now, once I have the parentheses gone, now I can multiply across the top. This is going to give me 8. Then when I multiply these same bases, what do I do with the exponents? I add them. You get t to the 18th over, now 27, right? 27 times 64 gives me 1728. And then t to the third. Now, right now I can go ahead and reduce, right, this fraction. Both of these can be divided by 2, or sorry, by 8. 8 divided by 8 is 1 over 216. But then when I go to do the t's, I can cancel out 3 t's off the bottom, 3 t's off the top, which means I have 15 left. So t to the 15th, and this is your final answer. All right. Now, right here, everything inside this parentheses, all of this, is going to get raised to the 4th power. So 2 to the 4th, you have to remember, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Then when I raise a power to a power, I multiply. So c to the 3 times 4 is 12. D to the 5 times 4 is 20 over 5 to the 4th. It's going to give me 625. It's because 5 times 5 is 25, times 5 is 125, times 5 is 625. Then C to the 4th, D to the 3rd to the 4th, multiply those together to get D to the 12th. Then finally, G to the 2 times 4 is 8. So when I raise these powers to a power, when I raise all of these exponents to the 4th power, I'm multiplying those exponents. Now I can go ahead and cancel. So 16 over 25 cannot be reduced, but 4 c's cancel 4 c's off the top to give me 8 left over. So c to the 8th. 12 d's eliminate 12 off the top. I have 8 left, so over d to the 8th. I have no g's to cancel out, so I keep g to the 8th on bottom. All right. Now number 8. These are going to be tough problems, right? But hopefully, they won't be too bad for you. So let's take a look at this one real quickly. It's not the end all be all if you don't get it, but I'm hoping we can get to the point where they're not bad. So right away, when I raise negative 7 to the 4th power, that's going to give you 24 over 1, 2401. Now, x to the 4th to the 4th, multiply the exponents to get x to the 16th. Y to the 7th to the 4th is y to the 28th. Z to the 32nd. Remember, you're multiplying all of these exponents. So then it'd be x to the 4th, y to the 8th. That's what I get when I simplify this first quantity. But I still have that 3x to the 6th, y to the 2nd, over x to the 5th, z to the 6th. So now I'm going to multiply up top, multiply down bottom, and then I'm going to reduce. So 2401. Now remember, when I multiply these x's, I'm going to add the exponents. So it'd be x to the 22nd, y to the 28 plus 2 is 30, and then z to the 32nd. But I forgot to multiply 2401 times 3. So this is actually going to be 7